Denmark has decided to become independent from fossil fuels for the sake of the climate, the economy, and in order to ensure the security of supply. At present, wind and solar energy already delivers a good share of Denmark's energy, and this development will continue. But renewable energy is a major challenge for an energy system that is built upon fossil fuels. Energy production from wind and solar fluctuates. It fluctuates as the wind blows. So what renewables are reliable when there is no sun or wind energy available? Another challenge is the transport sector. How do we create an energy system of renewable energy where also cars, ships and planes can operate on fossil-free energy? A great example of an energy system that will ensure Denmark a 100% renewable energy system is called Smart Energy Systems, a coherent fossil-free energy system that will create lots of new jobs and green energy for the Danes, both in terms of electricity, heat and transport. Wind, solar and wave power will provide 50% of Denmark's energy in the future. The remaining 50% of our energy production will mainly come from non-food-based biomass, wood and straw, all provided by Danish agriculture and forestry. In the smart energy system, the use of biomass is carefully assessed so that it does not become unsustainable. It is important that Denmark does not overconsume biomass, since this will start to affect other sectors such as food production. Therefore, the biomass needs to be used efficiently and correctly. A good share of straw and wood is already used directly as fuel in Danish CHP plants today. With new technology, biomass, straw and wood can be utilized to create even more energy. This will be done through the production of green gas, respectively through classic biogas production and thermal gasification. In thermal gasification, the organic material is heated. The high temperature means that gas is evolved. The process has a very high efficiency. Another part of the green gas will come from classic biogas production. The production of biogas will be based on manure and other agricultural byproducts, as well as waste from households and industry. The ambition is that agriculture must provide 1/3 of Denmark's future energy production. The biogas will typically be produced in facilities such as here, at the biogas plant in Gårdstrup near Hjørring in the northern region of Denmark. 88% of the biomass the plant uses comes from aerial farms that transport approximately 300,000 tons of manure to the plant. The rest comes from energy crops. Gas production from the biogas plant at Hjørring corresponds to approximately 5,000 households' annual consumption of natural gas. Other places in Denmark, the manure will be transported in pipes to a common biogas plant. The biogas is produced by anaerobic gasification, a process that requires the biomass to be heated to 38 to 52 degrees. When the gas is extracted, the digested manure is transported back to the farm. The digested manure that comes back to the farm smells significantly less, and the fertilizer from the digested manure is absorbed much better by crops in the fields. The green gas can be used in different ways in the energy system. Part of it will be used directly at the CHP plants, where the turbines will be converted from coal to gas. Other parts of it will be used for fuel cells. Gas turbines and fuel cells are very efficient and can quickly be switched on and off. This creates flexible power plants that effectively can adapt production to the fluctuating energy from sun and wind. The CHP plants will hereby continue to be an important part of the Danish energy system. The electricity produced at CHP plants is sent to the national power grid. In total, the green gas, wind and solar could produce all the electricity Danes need. The large amount of heat, which is a residue from the CHP electricity production, will be allocated to the 405 local district heating suppliers, who are spread out across the country. The district heating system in Denmark supplies around 1.6 million houses with heating. The district heating system connects the electricity sector to the heating sector. When there is a surplus of wind power, the combined heat and power plants can reduce their electricity and heat production. And large-scale heat pumps can produce heat which can be stored in a thermal storage. The many homes outside the urban district heating systems will be supplied with heat from heat pumps that get their energy from the power grid. Heat pumps require burial of a water pipe to about 1 meter in depth, as it uses the difference between the temperature in the air and in the ground. Solar panels on the roof of private housing or large commercial plants are already a great part of the heat supply system in Denmark and are to be expanded. In addition, heat will also be produced from geothermal plants, where heat is extracted from the high temperatures underground. Electric cars are a way to use renewable energy in the transport sector, but electric cars cannot do it alone. New technologies and solutions must come into play to ensure renewable energy for the entire transport sector. One of these new technologies is the conversion of green gas, a conversion which is completed at a so-called hydrogenation plant. Such a plant is currently being planned for construction in Hobro in the northern region. At the hydrogenation plant, the green gas is boosted with hydrogen and CO2. The CO2 is extracted from the smoke at the CHP plants, and hydrogen is produced by a surplus of electricity, which is generated when wind turbines produce more energy than what is needed. The hydrogen is produced through electrolysis and use electricity to split water into hydrogen and oxygen. A variety of liquid and gaseous fuels can be produced from the hydrogenation. Liquid fuels such as methanol and dimethyl ether, DME. In the smart energy systems, methanol is used to supply the cars which cannot be converted to electric vehicles. The green gas can also be used directly in the transport sector. This will require gas tank stations and a conversion of car engines. Direct use of electricity should be priority number 1. However, green gas may be used to supplement, most likely in trucks and ships. Green gas can also be applied to the national natural gas grid. Green gas is, in fact, when it is cleaned, chemically the same as natural gas. The natural gas grid allows for storage of great amounts of gas. It occurs in caverns, which are large cavities in the underground. Here it is possible to store 25% of Denmark's annual gas consumption. As the natural gas in the North Sea runs out, it is possible for green gas to gradually replace natural gas in the Danish gas system. At the same time, green gas can create the much-needed balance between production and consumption in the Danish energy system. When there is a lot of sun and wind, then they produce green gas. And when there is less sun and wind, they use green gas.